And you can see we have just a basic demo model here, and we have our CAD object that's properly aligned to our coordinate system. And then from there, we have our 3D scan file that is kind of arbitrarily out in space. So this is traditional with any sort of 3D scan based inspection, where we have a really good, clean looking object here, but it's not located in the correct coordinate system. So that's usually going to be problem number one with a process like this, where we need to get these to repeatably and accurately align to another. The first thing we generally run through is an initial alignment. This initial alignment process is very simple and very straightforward. Basically, the software is going to look for similarities between the two objects and snap those two objects together. But that is one part that's really crucial for our replace measured data processes. So we always recommend that customers do that. And once that process has been done, now we can go through and refine those alignments a little bit more. So we've got both of our parts close to one another at this particular point. And now what I'll do is I'll set up a datum-based alignment. So this datum alignment runs a hierarchy through these pairs. And with that pairing, we're able to very precisely control what CAD services we're using to align our scan file to our pre-existing CAD object. And you can see we do that just by clicking on those objects on the part, and it automatically snaps everything to it. So from here, what we traditionally recommend doing is, once we have our datum alignment finalized, we're going to take this over to a 3D comparison process. This 3D comparison process is a really good baseline for doing inspections where either we don't have prints that we're wanting to work off of yet for like R&D type applications, or if there's some problematic places on our parts that we want a really good visual understanding of, we can simply just run this 3D comparison process. With that, we can change our maximum and minimum search ranges, as well as our tolerance. And in turn, what we get is this really nice color map that's showing us all of our deviations through a specified range. So anywhere from 0.1 millimeters all the way down to 0.02 millimeters or 20 microns, we're going to have this color gradient that shows us where our part is in and out of tolerance. From there, we'll go ahead and maybe start breaking this down a little bit. So to break it down, traditionally what we'll do is maybe start out with a couple of 2D slices through our part. So we'll do just one slice right across our Z-axis. And with that slice, what we're getting is a basic color profile of the deviation of our physical object from our CAD object. We can also in turn change our whisker multiplier values for this. So if we want to get a really good visualization of how our part is deviating from the CAD object, we can magnify that through this whisker multiplier and start to see where we're falling in and out of specs on our part. After that, if we wanted to drop a few comparison points in, we can do that fairly easily just by selecting locations on our part, which in turn will give us our callouts for those locations. So if we want to identify high and low values, we can very quickly do that, and in turn get those built into a report that we want to take a look at later down the line. So now that we have the visual aspect of this achieved, let's go ahead and get some hard numbers from the file itself. And to do that, we're going to go over to our Dimensions tab, and we've got a couple of different tool sets in here. We've got our 2D dimensions that we can do. We've also got our 3D dimension tools, which are traditionally used a lot more extensively in the applications that we tend to run with. So to use our 3D GD&T tool sets, we've got a couple of different options here, but we're going to start out with our smart dimensioning tools. And our smart dimensioning tools are fantastic because what they allow you to do is select pre-existing geometry on our CAD object. So right now I've got two different cylinders, and it automatically pulls the axes of that object, we're able to put that angle value in 3D space, position it where we want to on our part, and then we also get all of our measured data here down at the bottom. So we can see our nominal value was 90. We're getting a value of 89.7688 for our actual value. And with that, we can see what our deltas are off of this part, being at that 0.2312 value set. So for this particular application, we'll say that is within spec. However, if we wanted to change that, we can very quickly and easily change our tolerancing right here inside of our Smart Dimension tool for any value that we so choose. We can in turn take these measurements as often or as little as we want. I went ahead and pulled a linear measurement from this cylinder axis to that planar surface. We can also in turn just click on a diameter to get that diameter value very quickly and easily. And we can take more linear measurements as we need to. So you can see how we can very quickly just run through our part, pull all those pieces and put our tolerances in place in order to get a true understanding of whether or not our part is inside or outside of spec. From there, we can take this one step further. That's our basic 3D measurements, but what about GD&T? So with our GD&T values, we can very easily come in here and assign datums to our part. And with those datums put in place, we can very quickly go through and set up a lot more complex GD&T type values. So with this, I went ahead and just put a couple basic datums in a few different coordinates here. And with that, we can check for concentricity, we can check for our perpendicularities, parallelisms, true positions. And just to do a simple run through on that, let's take, say, this top surface here. And let's check our parallelism value for that in relationship to our datum B, which is going to be this bottom planar value here. And you can see we go ahead and get this parallelism call out here down at the bottom. We go ahead and check that off. Let's maybe do a concentricity value. So we can do that simply by just selecting a cylinder on the CAD and assigning that to our datum structure. So we'll check concentricity to, say, our datum A. Actually, we need to back that up just a little bit. And instead, we're going to pull this one since that was the datum that we wanted to pull off of. So we're going to pull concentricity for that from datum C. And now we have that datum C concentricity value assigned to that particular feature there. And the list goes on, whether we want to do angularities, true positions, or you name it, here on this list, we're able to very quickly and easily do that. But there's a lot more power to this than just being able to manually pull various values off of our part like we're doing here. Let's say we wanted to pull true position of the inside profiles of this tooth all the way around our part. Well, we can assign a true position value to this one particular location. I'm going to go ahead and put our datum structure set through there. So we're just going to call out A, B, and C. And we can see that defines this particular value here for that particular location. But we have a pattern all the way across our part for this. So we can very easily come in here and press our pattern checkbox. And you can see after just a couple of moments, it runs through and populates all of these particular values and puts those into our pattern set. So this is a massive time saver when it comes to dealing with either positional values, pattern diameters, or you name it. We can very quickly come in and gather all of that information that we need with a click of just a couple of buttons. And then finally, with all of this, let's go ahead and show how we generate reports. Report generation is very simple inside of Control X. all we have to do is press our generate report option, and then we can select what we want to throw into that report and then press generate, and Control X Essentials will automatically build this report out for us. And once that's done, we can choose what we want to do with this report. So we can set up our department, part names, all the information that you want to put into our report, as well as we have the ability to save these reports off as our PDFs, Excels, or PowerPoint values, so that you can look at this information exactly as you need to. And finally, let's talk a little bit more about our replace measured data option. So this replace measured data is a really important feature inside of Control X. With this feature set, we're able to repeat everything that we did here in just a couple of moments. So to do that, let's go ahead and press replace measured data. And then we'll go ahead and just select a duplicate of this part. And what it's going to do is it's going to go ahead and replace the pre-existing STL file that we have in here with another STL file of the same object, which we can then in turn have aligned and then pull all of the comparison values from that part in a very simple way. With the click of just one button, we're able to generate all of this information and then pull a report together for that. You can see it sitting here running through that process. So as it runs through that process, I'm going to take just a couple of moments here to look at any questions that have come in so far, and we will address those here in just a few moments. So you can see now we've got our new object pulled in, and we have all of these different values that have been assigned to it, all very easily identified here across our objects. We can go in and generate a report again in a very quick and simple manner to be able to take that information and put it wherever it needs to be analyzed. So that's just a very cursory glance at what we can do with Control X Essentials. There's a lot of different workflows that we can work through, which we'll discuss in future webinars. One workflow to just kind of give you a basic idea is, let's say we didn't want to have to deal with an STL model in the background of our object. We can very easily create all of our GD&T alignments and everything for our part, primarily just on our CAD. If you notice through the workflow that I was doing, there's nothing where we actually directly needed the scan file to be present for that. So we can set up our initial alignments, our datum-based alignments, all of the particular features that need to be inspected. And we can lay all that out directly on our CAD object, which for certain users can save some time. And it also allows you to have this inspection process set up in such a way to where when you're ready to do inspections on parts, all we have to do is bring in that replace measured data tool, and we can pull our STL file in, run the inspection process, and then generate the report off of that part. There's also capabilities that we have for doing scan-to-scan based measurements, where if we wanted to do basic feature creation on parts and do direct analysis of those features without pre-existing CAD objects, we have a couple of really good workflows for making that happen as well. So those are just some of the basics of Geomagic Control X Essentials, and it's a really exciting new product because it takes everything that 80% of our customers would use inside of Control X, and it puts that all together into one very simple, straightforward package that's easy to use, easy to understand, and easy to implement at an affordable solution.